Section 11.3 Hypothesis Test for Linear Correlation. Hypothesis test for the population correlation coefficient, rho. When we study two quantitative variables, we often want to know if there is a linear relationship between them. The sample correlation coefficient R measures the strength and direction of this relationship. However, even if R is not zero, it could be due to the random chance in the sample. To determine whether the observed correlation is statistically significant, we perform hypothesis tests for the population correlation coefficient, rho. So this is the notation for the population correlation coefficient. We won't be able to know about this number. And the R, this is called the sample correlation coefficient. We learned how to find it in the previous sessions. And we calculate from the sample data. Now, let's look at how to perform hypothesis tests for the population correlation coefficient. We'll be using the t-distribution. First, verify the conditions. The sample of paired data is a simple random sample of quantitative data. Visual examination of the scatter plot must confirm that the points approximate a straight line pattern. So we need to input the sample data to the TI-84 calculator. And then we're going to look at the scatter plot. Make sure all those points approximate a straight line pattern. If there is outlier on the scatter plot, we need to be removed before we finding the R. Step 2. Identify the null and alternate hypothesis. We always test the population one, okay? So you're gonna see this is the population correlation coefficient. We call this is the rho equal to 0. And alternate hypothesis will be rho not equal to 0. So think about it. Remember on the previous sessions, when we have the R, the sample correlation coefficient, R equal to 0. That means there is not a significant linear relationship, right? When the rho not equal to 0, that means there is a significant linear relationship. You also can test rho less than 0. When rho less than 0 means they do have the negative linear relationship. Or the rho can be greater than 0, then there is a positive linear relationship. But for our case, we only want to see if there is a significant linear relationship. So your null and alternate hypothesis is always looks like this guy. Okay, equal to 0 and not equal to 0. And when the alternate hypothesis is not equal to 0, we are working on two-tail tests. When the rho is approximately equal to 0, this means there is a very small or no relationship between the explanatory and response variable. However, when the rho is far from 0, then there is a significant relationship between the explanatory and response variable, whether it will be positive or negative linear relationship. Okay, first step, verify the condition. Second step, state the null and alternate hypothesis. Step 3, compute the test statistic. So this is the formula to find out your test statistic. And again, we'll be using the t-distribution. Okay, find the p-value and interpret the p-value. So this is gonna be the two-tail test, right? Because the alternate hypothesis will not equal to 0. And then we already find out the test statistic from the step 3 here. So p-value will be the area of this two-tail. Okay, so how can we find the p-value? We'll be using the t-CDF, and the lower value depends on your test statistic. Okay, if your test statistic is negative, then your lower value will be negative 1e99 upper value will be the test statistic. And then the degree of freedom, n minus 2. If your test statistic is going to be positive number, then your lower value will be your test statistic. Upper value, that will be 1e99. And then again, degree of freedom, that's an n minus 2. And talking about how many sample data do you have. And make sure you multiply by 2 because you do have a 2 tails. After you find the p-value, you're going to compare with your significance level. When it's a less than or equal to, you're going to reject. Strictly greater than, that will be fail to reject. Okay, step 5, conclusion. You're going to make the conclusion regarding the claim statement. Let's say if you reject the null hypothesis, then you're going to say there is sufficient evidence to conclude that there is a significant linear relationship between two variables. So make sure you guys state what kind of the variables do you have in here. But if you fail to reject, then you're going to say there is not sufficient evidence to conclude that there is a significant linear relationship between two variables. Okay, now let's work on the example together. Conduct a formal hypothesis test of the claim of linear correlation between the cost of the pizza and the subway fare. So first, verify the condition. This is going to be simple random sample, and we need to do the visual examination of the scatter plot. Okay, let's try to do it together. Input this data on your calculator. L1 will be the cost of the pizza. L2, that will be the subway fare. Okay, go to the stat. Number 1 added. And then input the cost of the pizza on the L1. Okay, then go to the stat, go to the test, go up, you're gonna find the linear regression t-test. Enter. My x data is on L1, y data is on L2. Frequency, just put 1. And we always choose not equal to. For the regression equation, we just leave it blank. And then go to calculate. Enter. So first, we do have the R here. R will be equal to 0.98781. Okay, you could write down this number first. We're going to use it for finding the test statistic. And you could find the test statistic here, 12.692. And also the p-value and the degree of freedom. You could write it down all this information. Okay, then you could double check your work. Now, after that, we're gonna look at the scatter plot. So we're gonna go second stat plot. I'm gonna turn on the first one. Choose the first icon. Okay. And then I'm gonna click zoom. Number 9, zoom stat. Okay, you're gonna see this picture. So visual examination of the scatter plot. We look at it. We do have approximate a straight line pattern. This fulfill our requirements. Okay, so I have this picture. Okay, you don't have to get the regression equation. Okay, both of them are good. And then we're gonna make sure we don't have any outliers. Okay. Now, we're gonna look at the null and alternate hypothesis. Null hypothesis will be rho equal to 0, means there is not a significant linear correlation. and then alternate hypothesis will not equal to 0. So there is a significant linear correlation. And again, this is going to be the two-tailed test. Okay, step 3, compute the test statistic. We have this formula, and then we just write it down for the R, right? I want you guys try plug in the R here, and then use your calculator to see what you're gonna get. Okay, check your work. You should get 12.692. And then find the p-value. So we have the two-tailed test. We need to figure out what is the p-value. P-value will be equal to the area of these two tails. And then we'll be finding the degree of freedom, which is going to be n minus 2. Okay, n minus 2, you could look at the denominator of this part. Right? That will be 6 minus 2, which is going to be equal to 4. And then T, C, D, F, make sure you're going to be multiplied by 2 because you do have a two-tail. Okay, lower value, that will be 12.692 here. And then upper value, that will be 1E99, and then degree of freedom. We just calculate the area of white tail. Then we need to multiply by 2 because we do have the left tail here also. You should get 0.0002.22. The p-value is very, very small. And remember that when you have a small p-value, you do have a strong evidence to support the alternate hypothesis. Then interpret. We compare with your significance level, so we're going to reject the null hypothesis. Okay, now draw the conclusion. There is sufficient evidence to support the claim of linear correlation between the two variables. Okay, don't just put the two variables. Write it down, the cost of the pizza and the subway fare. And again, double check with your calculator. Okay, you could do it one more time. Okay, your T, your test statistic, 12.692. Degree of freedom equal to 4. And the p-value, 2.22 times 10 to the power of negative 4. Okay, right? Okay, example 2. I want you guys try to do it by yourself. First, verify the condition. So first, simple random sample and visual examination of the scatter plot. So plug into your calculator, you should have this picture. Right? They do have the straight line pattern and there is no outlier. Okay, the null and alternate hypothesis. They'll be equal to 0 and not equal to 0. Two-tailed test. Okay, step 3. Compute the test statistic. Use your calculator to figure out what is your sample correlation coefficient R. Plug it in. be careful, this is going to be the negative, right? And this is R squared, so the negative should be within the parenthesis. When you take square, the negative will goes away. And then you should get negative 5.858. Okay, p-value to tell, and this time my test statistic is going to be negative, right? Okay, first find out the degree of freedom. Look at here. And minus 2, which is going to be equal to 3. And then TCDF, lower value will be negative 1E99, upper value that will be negative 5.858. Degree of freedom that will be equal to 3. Okay, right? And then multiply by 2 because you do have 2 tails. You should get 0.0050. Okay, compare with your significance level, which is going to be less than or equal to. And then we're going to reject it. So draw the conclusion. There is sufficient evidence to support the claim that there is a linear correlation between weight of lemons import from the Mexico and then United States car fatality rates. That's it.